So continuing on 2.1 in Trig, we left off with example 2. We figured out that it was a right triangle. Now we're going to find the area. So we left off with the area of a triangle is 1/2 times the base times the height, but now we need the distances of the sides. So I need the base, which is side AC, and I need the height, which is side BC. So I need to find the distance now of AC and BC.
Sweet mother of God!
So those are my points. The base we said was AC, so there's A, there's C, so x1, y1, x2, y2, and there is the distance formula. All this is substitution. Take each value and plug it in. That's all that I'm doing there. So that's why it's a 2 minus -1, and a -5 minus a -3. So plus a positive, that becomes 3 squared, plus a positive, that's -2 squared. 3 squared is 9. -2 squared is 4, so I get square root of 13. So next up is the height. The height is BC. So x1, y1, x2, y2. Distance formula again, so I plug it in. So that's 2 minus 6. -5 minus 1, which gives me a -4 squared and a -6 squared. So I get 16 and 36, which is the square root of 52. So according to the formula, 1/2 times the base times the height, I'm going to get 1/2 times root 13 times root 52. It's basically what it is when I substitute it in. So 13 times 52 is 676. That goes in the root underneath, and the square root of 676 happens to be 26. Half times 26 is 13, so the area of that triangle is 13.
Sounds like a case of the Mondays.
So taking a look at the graphs again, we're given points A, B, and C, so I'm going to plot those. Prove that C is the perpendicular bisector of segment AB is what we're going to try to prove. So 1, 7, right? 1, 1, 2, 3, 4, 5, 6, 7 is right there. 1, 2, 3, 1, 2. There's point B. And then we're trying to prove that C is right in the middle. 1, 2, 3, 4.5. Right there. There's C. We're trying to prove that C is a perpendicular bisector. So what that means is, there's your line. We're trying to say that this point, if I was to draw a straight line, it will cross AB, and if I was to draw a straight line, it will not only cross it, but it will form a right angle. That's what we're going to try to sit there and find. But a perpendicular bisector means it's going to form a right angle and bisect it. Bisect it means it's going to cut it down the middle. Right down the middle is what that means. So, if C is a perpendicular bisector, okay, that means AC equals BC is basically what we're going to say. If it's a perpendicular bisector, then we know that AC and BC are going to be the same. And why do we know this? Because if this is going to cut it right down the middle, we're actually forming an isosceles triangle, and an isosceles triangle has two sides that are going to be equal, those two sides. That also cuts this in half, right? So if it cuts this in half, it's going to form two right triangles, and by side angle side, if you remember that from geometry, these sides also have to be equal, AC and BC. Okay, so for a variety of reasons there. So we just need to find the distance of AC and BC is really all that we have to do here.
Call Mr. Plow, that's my name, that name again is Mr. Plow.
So AC, there's A and C. So going to do the distance formula on A and C. So a 4 minus 1, and I, instead of writing it as a half, I just wrote it as 0.5 minus 7. So that's a 3 and a -6.5. So I get 9 plus 42.25, and I get the square root of 51.25. And I'm just going to leave it like that. Yes, you can get an exact answer, but the point is, if I just leave it like this, then it doesn't matter whether I get a decimal or whatever I get. But it won't matter then at all what I get. So we take a look now at BC. and I plug that in. There's x1, y1, x2, and y2. So I plug it in. It's a 4 minus a negative 3 squared, and 0.5 minus a 2 now squared. So that gives me 7 squared and negative 1.5 squared, which is 49 plus 2.25. And if you notice, that's why I didn't have to go the whole way through to get a small decimal, because those two are exactly the same, which means whatever decimal they give, they're both going to give me the same decimal. And they're the same, which means that is a perpendicular bisector. So C is in the middle of the 2 points, and thus proves that C is a perpendicular